The first question about life that has always engaged man's imagination is the following: how can life have developed from inorganic matter? The ancient Greeks answered this question by saying that life is spontaneously generated from inorganic matter as a result of the goddess Gaia. This hypothesis was reformulated by the Latins as generatio spontanea, and from contemporary science as abiogenesis. In 1668, Francesco Redi showed that the most complex forms of life cannot arise spontaneously from inorganic matter, and thus refuted, at least in part, the hypothesis of spontaneous generation. Francesco Redi's demonstration was limited to complex forms, and the idea of spontaneous generation was therefore restricted to simple organic forms. In 1745, John Needham showed that sterilized chicken broth placed in a sterile container led to the formation of microbes. This demonstration gave new impetus to the hypothesis of spontaneous generation. In 1768, Lazzaro Spallanzani replicated Needham's experiments, removing the air from sterile containers and arriving at the demonstration that no spontaneous generation of microbes is observed. In the mid-19th century, the French Academy of Sciences awarded a prize for anyone who was able to convincingly answer the question about spontaneous generation with exact experiments. The prize was won in 1864 by Louis Pasteur, who, with a series of brilliant experiments similar to those conducted by Needham and Spallanzani, showed that microorganisms do not develop spontaneously in sterile containers. Pasteur summed up his results in the Latin phrase omne vivum ex vivo, indicating that life can only be generated from organic living matter. The search was further restricted to spatial conditions that would have characterized Earth. In 1924, Alexander Oparin published a work titled The Origins of Life. Oparin suggested that the ability of colloids to build substances to the surface indicated an onset of metabolism. In 1952, Harold Urey coined the term cosmochemistry to indicate the study of chemical elements on Earth and in the stars during their evolution. In the 1952 books The Planets, Their Origin and Development, Urey hypothesized that the composition of the primordial Earth's atmosphere was similar to that of the elements of the cosmos. 90% in hydrogen atoms, 9% in helium atoms, 1% in atoms of other elements. From this, he deduced that the composition of the primordial atmosphere must have been of methane, ammonia, nitrogen, water, and hydrogen. In 1953, Stanley Miller published the article A Production of Amino Acids in possible primitive Earth conditions. Miller, a student of Urey, demonstrated that in a primordial atmosphere, in the presence of water and under the action of electrical discharges which simulated lightning, amino acids, the basic building blocks of proteins, could be generated. In his experiments based on sterile equipment, Miller inserted gases such as methane, ammonia, and water. This system contained water and 2 electrodes. The experiment was divided into cycles in which water was heated to induce the formation of water vapor. The electrodes were used to produce electrical discharges similar to the lightning, and everything was then cooled to allow water to condense. At this point, a new cycle began. After about a week, in which conditions were held constant, Miller observed that about 15% of the carbon had formed organic compounds, including some amino acids. Miller's idea was that these synthetic amino acids could become the building blocks of proteins. In Miller's experiments, an aqueous mixture was formed containing various products which were then isolated, demonstrating the existence of amino acids, including some of those present in living beings. This aqueous mixture was called by Miller primordial broth. Amino acids are the building blocks of life, but they are not considered to be living forms. Miller's experiments gave rise to other experiments that aimed to describe how proteins can spontaneously form from amino acids. Proteins involved in cell metabolism are made up of chains comprising more than 90 amino acids. To combine amino acids into a protein, combinatory calculations show that we need at least 10 to 600, that is 1 followed by 600 zeros, combinations. That is a number consisting of 600 zeros. However, Walter Elsasser showed that in the history of our universe, combinations did not exceed 10 to 106, an incredibly smaller number. Spontaneous protein formation is comparable to puzzle pieces, which by themselves give shape to the final design. This is impossible without an intelligent guide. In other words, the possibility that only one protein was formed by chance is nil. Elsasser concludes, the notion of chance in biology has no logical basis. Its use to explain life is metaphorical at best, but there is a danger that this metaphor could lead attention in the wrong direction. Furthermore, the primordial broth consists mainly of water, but water leads to the decomposition of macromolecules and makes it impossible for amino acids to form proteins. In 2004, Luc Lemann and his collaborators obtained peptides, short chains of amino acids, using volcanic gas and metal sulfide catalysts. But using these processes, it is not clear where the amino acids came from, as these require totally different environment. Another idea is that amino acids, which are formed in water, are concentrated in lagoons which periodically dry up and condense under the influence of heat, which also creates the chemical bonds responsible for the union of amino acids. These processes produce 13 of the 20 amino acids involved in the construction of proteins. In addition to these, thousands of other amino acids are generated, which are not present in living organisms. If it were possible to select and combine only amino acids present in living systems, the result would be three-dimensional and non-linear proteinoids. Three-dimensional combinations are inadequate for cell metabolism because they cannot be encoded by a linear genetic code. Therefore, proteinoids have no value in the formation and development of life. Life, as we know it, is totally dependent on left-handed amino acids, while the synthesis of amino acids leads to the formation of an equal number of right-handed and left-handed chains. The production of proteins in laboratories is therefore not suitable for the formation of living organisms. These processes lead to the formation of monofunctional molecules that block the ends of the chains, making them inaccessible for further extensions, becoming an impediment to the development of proteins. In all the experimental approaches, in addition to the desired amino acids, many other substances are formed, which prevent subsequent steps. Let us now see how syntropy explains life. Syntropy arises from the energy-momentum-mass equation, which, being squared, has two solutions for energy: an energy that diverges forward in time and one that diverges backward in time. The energy that diverges backwards in time was considered impossible, and Einstein solved the problem by saying that since the speed of physical bodies is very low compared to the speed of light, we can consider the momentum equal to zero and return to the famous E equal mc squared. However, in subatomic world, the speed of the rotation of particles is close to the speed of light. For this reason, the extended energy-momentum-mass equation must be used in quantum mechanics, and syntropy becomes a fundamental element of quantum mechanics. In 1941, the mathematician Luigi Fantapia discovered that the positive time energy solution is governed by the law of entropy, that is, the tendency towards dissipation and thermal death, while the negative time solution is governed by the tendency to concentrate energy, increase differentiation, complexity, order, and structures. Fantapia coined the term syntropy to describe these properties, combining the Greek words syn, which means converge, and tropos, which means tendency. Fantapia saw in syntropy the mysterious properties of life and concluded that living systems are caused by the future. He presented this theory in a book titled The Unified Theory of the Physical and Biological World. Unified, as energy is a unity that cannot be created or destroyed, but has two aspects: the physical world of entropy and the biological world of syntropy. Syntropy is vital energy. Life is nourished by syntropy, but how does syntropy flow from the quantum level of matter to the macroscopic level of our physical reality, transforming inorganic matter into organic matter? In 1925, Wolfgang Pauli discovered the hydrogen bond. In water molecules, hydrogen atoms are in an intermediate position between the subatomic, quantum, and molecular levels of the macrocosm and provide a bridge that allows syntropy, the cohesive forces of life, to flow from the micro to the macro. Hydrogen bonds increase cohesive forces and make water different from all other liquids. Due to these cohesive forces, 10 times stronger than the van der Waals forces that hold other liquids together, water exhibits abnormal properties. For example, when water solidifies, it expands and floats. On the contrary, other liquids become denser, heavier, and sink. The uniqueness of water derives from the cohesive properties of syntropy that allow the formation of large-scale networks and structures. Hydrogen bonds allow syntropy to flow from the subatomic level to that of the macrocosm. For this reason, water is essential for life. Water is the lymph that carries syntropy, vital energy. Water is essential for the manifestation of any biological structure. Hydrogen bonds make water essential for life, providing syntropy to living systems. Water draws syntropy from the quantum level. Water is indispensable for the origin and evolution of any biological structure. Based on this consideration, in February 2011, we wrote an article for the Journal of Cosmology commenting on an article by Dr. Richard Hoover of NASA's Marshall Space Flight Center. Dr. Hoover had discovered microfossils similar to cyanobacteria in the intersection of comet meteorites, and using electron microscopy and other measurements, he concluded that they originated from these comets. According to syntropy, life is a general law of the universe that requires the presence of water to manifest itself. A characteristic of comets is that they are rich in ice, which near the sun melts and becomes water. Thus, in our article, we suggested that according to syntropy, living organisms can originate in extreme conditions, such as those of comets, and that the discovery of Dr. Hoover of cyanobacteria microfossils in comet meteorites is consistent with the theory of syntropy. Syntropy leads to a supercausal view of reality, where the present is the result of the interaction between causes that act from the past and attractors that act from the future. With causality, to increase the effect, it is necessary to increase the cause. Furthermore, the effects tend to disperse and fade out. With retrocausality, the effects tend to be amplified. This strange phenomenon was studied by the meteorologist Edward Lorenz, who in 1963, to describe it, used the phrase "a flapping of wings in the Amazon," can cause a hurricane in the United States. In homeopathy, it has been discovered that the more the active principle is diluted, the more powerful it becomes, reaching the paradox that when the active principle is diluted under the Avogadro's number, that is, when only one molecule is no longer present, it reaches its maximum power. However, this occurs only in the presence of water. Homeopathic preparations are diluted in water. Syntropy explains this strange phenomenon by saying that there is a continuous interaction with the attractors to which we are connected. On the one hand, we give information to the attractors, who, being syntropic, select only what is favorable to life. On the other hand, the attractors provide us with what they have selected. Attractors work as repeaters. They receive information from all the individuals and return information that has been selected and processed. This tells, for example, that species are characterized by attractors, although individuals can be very different, as is the case with dogs. They all share the same attractor. In the absence of attractors, if only causality existed, individuals would diverge. They would all be different from each other, and there could be no species. Hans Driesch, a pioneer of experimental research in embryology, has shown that a different kind of causality is at play in life. Driesch suggested that the existence of attractors, final causes that act from the global to the analytical, from the future to the past, and not from the analytical to the global and from the past to the future, as it happens with classical causality. For Driesch, final causes lead life to develop and evolve and coincide with the purpose, the biological potential. Final causes were indicated by Driesch as entelechy. Entelechy is a Greek word which means something which contains its own end or purpose and which evolves towards that end. So if the path of normal development is interrupted, the system can achieve the same end in other ways. For example, by dividing the cells of the sea urchin embryo after the first cell division, Driesch expected each cell to develop into the corresponding half of the animal for which it was designed or programmed, but instead he found that each cell developed in a complete sea urchin. This also happens in the fourth cell stage. Each develops a complete sea urchin, albeit smaller than usual. It is possible to remove pieces from the eggs, mix the blastomers, and interfere in many ways without affecting the final result. It seems that every single monad in the egg cell is able to form any part of the complete embryo. Conversely, when two young embryos are joined, a single sea urchin is obtained, and not two sea urchins. These results show the existence of a morphological purpose. When we act on an embryo, the surviving cells continue to respond to the final cause, to the attractor. Although smaller, the structure that is reached is similar to that which would have been obtained from the original embryo. It follows that the final form is not caused by the past or by a program, project, or design acting from the past, since any change we introduce in the past leads to the same result. Even when a part of the system is removed or normal development is disturbed, the final shape is reached, which is always the same. In 1926, the biophysicist Alexander Gurwitch and independently the biologist Paul Alfred Weiss suggested the existence of a new causal factor different from classical causality, which they named the morphogenetic field. Apart from the statement that morphogenetic fields play an important role in the control of morphogenesis, that is, the development of the shape of the body, none of the authors have shown how causality works in this field. The term field is currently in fashion: gravitational field, electromagnetic field, individual particle field, and morphogenetic field. However, the word field is used to describe something that is observed but not yet understood. These are events that require a new type of explanation based on a new type of causality. Syntropy replaces the term entelechies and fields with the term attractor. An attractor is a cause that acts from the future by generating a field. Rupert Sheldrake added the notion of formative causality, according to which morphogenesis, the development of form, is driven by attractors, which are retrocausal processes. One experiment Sheldrake describes is that members of the same group, such as animals of the same species, can share knowledge without using any physical transmission. Experiments show that when a mouse learns to solve a task, this solution is found faster by other mice of the same breed. The greater is the number of mice that learn to solve a task, the easier it becomes for each mouse of the same type to solve that task. For example, if mice are trained to solve a task in a lab in London, similar mice will learn to solve the same task more quickly in labs around the world. This effect occurs in the absence of known connections or communications between laboratories. The same is observed in the growth of crystals. The ease of crystallization increases with the number of times the operation has been performed, even when there is no way in which these crystallization nuclei could have contaminated each other. Sheldrake explains these strange results by introducing the concept of morphogenetic field. Syntropy explains these phenomena with the properties of attractors that function as repeaters, receive information and share it. Robert Rosen, theoretical biologist and professor of biophysics at the University of Louis, writes in the book Anticipatory Systems. I was amazed by the number of anticipatory behaviors observed at all levels of the organization of living systems that behave like real anticipatory systems, systems in which the present state changes according to the future, violating the law of causality according to which changes depend exclusively on past or present causes. We try to explain these behaviors with theories and models that exclude any possibility of anticipation. Without exception, all biological theories and models are classical. in the sense that they seek only causes in the past or present. To make anticipatory behaviors consistent with the idea that causes must always precede effects, predictive models and learning processes are taken into consideration. But anticipatory behaviors are also found in the simplest forms of life, such as cells, without neural systems, and in these cases it is difficult to support the hypothesis of predictive models or learning processes. Furthermore, they are also observed in macromolecules, and this excludes any possible explanation based on innate processes due to natural selection. Rosen concludes that a new causality is needed to explain the anticipatory behaviors of living systems. In this regard, Albert Szent-Györgyi, Nobel Prize in Physiology in 1937 and discoverer of vitamin C, writes, "It is impossible to explain the qualities of organization and order of living systems starting from the entropic laws of the macrocosm. This is one of the paradoxes of modern biology. The properties of living systems are opposed to the law of entropy that governs the macrocosm. One of the main differences between the amoebas and humans is the increase in complexity, which presupposes the existence of a mechanism that can counteract the law of entropy. In other words, there must be a force that is able to counteract the universal tendency of matter towards chaos and energy towards heat death. Life continuously shows a decrease in entropy and an increase in its internal complexity, and often in the complexity of the environment, in direct opposition to the law of entropy. We observe a profound difference between the organic and inorganic systems. As a man of science, I cannot believe that the laws of physics lose their validity as soon as we enter the living systems. The law of entropy does not govern living systems. And the paleontologist Teilhard de Chardin concludes that, reduced to its essence, the problem of life can be expressed like this: accepting the two principles of conservation of energy and entropy, how can they assimilate without contradiction a third universal law which is expressed by biology, that of the organization of energy? The situation becomes clear when we consider at the basis of cosmology the existence of a sort of anti-entropy. Experiments on retrocausality show that we feel the future in the form of emotions. When we are moving towards the tractor, our life is filled with syntropy, that is, with converging energy, warmth, and well-being. When we are not going towards the tractor, we perceive emptiness, suffering, and death. These feelings can be used as the needle of a compass that tells us which direction we need to follow. We continually use these feelings, often unconsciously. Between 1950 and 1955, William Cox conducted studies on the number of tickets sold in the United States for commuter trains and found that in the 28 cases where trains had accidents, fewer tickets were sold. This reduction was strong not only from a statistical point of view, but also from a quantitative point of view. Cox made all possible checks, such as adverse weather conditions, departure times, the day of the week. However, the decline in ticket sales for trains that had accidents always remained marked. Lacking a theory that could explain these results, the papers were published in journals of parapsychology. Syntropy explains Cox's findings in this way. When people are involved in accidents, they feel pain, fear, and death. These feelings propagate towards the past, backwards in time, and they are felt in the past by the same person as pain, fear, and death, negative feelings that warn that something is about to happen. The person in the past may at this point decide not to travel or simply feels physically ill. In other words, a negative event occurs and informs us in the past through our feelings. Among the many possible examples, on May 22, 2010, an Air India Express Boeing 737-800 flying between Dubai and Mangalore crashed during landing, killing 158 passengers. Only 8 survived. It is important to note that 9 passengers after check-in felt ill at the time of boarding and did not enter the plane. The article in Battle Hunches proved to be valuable, published on the front page of the New York Times on July 28, 2009, describes how feelings and premonitions helped soldiers save their lives. My body suddenly went cold, you know, that feeling of danger, and I started screaming, "No, no!" According to Syntropy, the attack occurs, the soldier experiences fear and death, and these feelings propagate backward in time. In the past, the soldier feels fear and death and makes a different decision, thus avoiding the attack. According to the New York Times article, these premonitions have saved more lives than the billions of dollars spent on intelligence. These feelings can be mainly of 2 types, positive or negative, and they warn us about what is about to happen, without telling us what is about to happen. For example, last July, I started feeling strong negative feelings and strong positive feelings. I was sure something was going to happen. After a couple of days, I woke up early in the morning and found my car wrecked. A SUV with 2 young couples had crashed into my car. Fortunately, my car diverted them and prevented them from falling into the ravine below, where they would have died. When this event took place, the strong feelings of premonition that I had for a few days vanished. On the one hand, the annoyance and problems caused by the wrecked car. On the other, the feeling of having saved 4 lives. Henry Poincare, one of the most creative mathematicians of the last century, noted that when he was faced with a new mathematical problem with infinite possibilities, initially he used a rational approach, but not being able to arrive at the solution, another type of process was activated. Poincare indicated it as intuition and was struck by the fact that it is always accompanied by feelings of truth, beauty, warmth, and well-being in the heart area, which highlight the correct solution among the infinite possibilities. From an early age, I began to use this intuitive thinking to quickly find the correct solutions to complex problems, and I was soon considered a genius in mathematics. People were asking me how I managed to find solutions to complex problems so instantly. I tried to explain the trick of the feelings of the heart that illuminate the solution, but no one understood what I was trying to say. The neurophysiologist Antonio Damasio found that people with decision-making deficits who are unable to make advantageous choices show alterations in the ability to feel emotions. They have intact cognitive functions: memory, attention, perception, language, abstract logic, arithmetic ability, intelligence, and learning are intact. But they don't feel emotions, and this causes a myopia towards the future, which leads to not being able to plan the future even for the hours to come. Decision-making deficits show that there is a set of systems oriented towards the future, towards an end, and that this is at the basis of decision-making processes, and it is guided by feelings. Individuals with decision-making deficits are characterized by knowledge but not feelings. A very simple example which has puzzled many researchers is provided by the strategy cats use when they want to jump on a table. They are not able to see what is on the table, but they smell the food and want to get on the table. They start walking around the table until they choose a spot. Then they begin to evaluate the jump by moving their butt in slow motion. But what are they evaluating, since it's impossible for them to see the top of the table? However, when they jump, they land perfectly in the tightest spots. According to the retrocausal hypothesis, cats start a game that, thanks to their feelings, leads them to the future outcome, thus selecting the most advantageous option. They try infinite virtual jumps and feel the result. When the feeling is positive, they know that this is the right jump, and they jump. Syntropy suggests that life continually plays with the future, thanks to emotions and intuitions. Feelings and emotions guide to the attractors. And in the attractor, there are projects that are the optimal combination of the information that comes from all the individuals connected with the attractor. There are many attractors, one for each species, but also one for each organ. DNA functions as quantum antennae that connect to the attractors. The information is therefore not contained in our body, but in the attractors, which are found in the quantum unitary space. Therefore, different species that share some characteristics are not necessarily related to each other. For example, whales and dolphins are believed to descend from the small deer that walked the surface 50 million years ago, since their teeth have same characteristics. According to syntropy, the same attractors can be used even though there has never been any physical connection. According to Syntropy, all living species are finalized, are born and formed for a purpose. They are not the product of chance. The finality coincides with the attractor of the species. When a new purpose is formed, the attractor of this new species goes shopping for the components he needs. For example, the sub-attractor of the eye, ears, and all the other organs that are needed. For each organ there is a huge variety of attractors. A bit like what happens in computer programming using objects, an organ does not have to be redesigned, since an attractor, an existing project, can be used by modifying some parameters. This explains why species are not found while developing new organs, but organs suddenly appear already formed. This store of attractors is not material, but is in the realm of quantum physics, of unitary space. This allows to use attractors, projects, developed in any other part of the galaxy. When a species is formed, the information is contained in the attractor of the species. This means that if it is extinct, the information continues to exist in the attractor. For example, for over 3 million years, warm periods alternate to glacial periods that are becoming colder and longer. At the peak of the last ice age, the ice exceeded 4 kilometers in thickness at latitudes such as that of Rome. The ice age led to the total extinction of pre-glacial humanity. The remains of this pre-glacial humanity show that it was very similar to us, except for their size, which was gigantic. During the Ice Age, this race of humans became extinct. And 11,700 years ago, with the return of the interglacial hot era, the conditions for having mankind on Earth reappeared. Thanks to the attractor of mankind that already existed, the evolutionary stages did not have to be repeated, but humans took shape almost instantly, but modifying some parameters such as, for example, height. The new humans did not keep track of the previous pre-glacial civilization and had to start the civilization process from scratch. This is why the oldest traces of our civilization date back to 11,700 years ago, when the Ice Age ended. Civilization was impossible during the Ice Age. The traces of civilization that existed in the last warm interglacial period 120,000 years ago have been erased by time. For more information, the website syntropia.it allows to download for free books on the topic, including The Origin of Life.